Alright, so there's something a little funny that happens when you're dealing with two, not just lines cut by a transversal, but two parallel lines cut by a transversal. Something kind of funny happens. If we look at this picture down here, and we're told that lines M and L are cut by, are parallel, I'm sorry, that they're parallel. First things first, let's go ahead and let's label these two lines, M and L, to show that they're parallel. What symbol shows that two lines are parallel? Well, you may not know, but now you know. There's this little triangle that's filled in on each of these lines. That means that these lines are parallel. If you don't see that, you can't just assume that they are. You either need to be told that they are parallel, or you need to see those symbols, then you know they are parallel. And if you don't see them, and they tell you that they're parallel, you need to put those on there so that you know, it refreshes your memory as you're going through the problem, hey, these two are parallel, that's an important thing. Okay? And we are also told that line P is the transversal that cuts through them. So my transversal is this guy right here. Okay, that's my transversal. Here's the funny thing that happens. When you have two parallel lines cut by a transversal, every angle pair is either congruent or supplementary. And let's throw an exclamation point on that. That's the funny thing that happens. Okay? You may not think it's funny right now, but it is funny. So every angle pair is either congruent or supplementary. You can kind of write that up under here. You can put it down here right above the picture so that it reminds you. It's up to you. Here's the reason why every angle pair is either congruent or supplementary. If you think of the idea of a line having 180 degrees in it, I'm only given one angle out of the 8 down here on this picture, and it's this angle that's 54 degrees. When that angle of 54 is added to this angle right here, together those two angles make up this line. So if I take 180 degrees, which is, remember, supplementary means two angles that add to 180. If I take 180 and subtract 54 from 180, 180 minus 54 is going to leave me with, let's see here, 126 degrees. I know this angle here to be 126 degrees without doing any work other than simply subtracting 54 from 180. The thing about this is that this line also, when you look at the 54 degree angle, these two angles together also make up a straight line. So I know this over here to also be 126 degrees. Because adding, 126 plus 54 gives me 180. If I go a step further, and I look at, say, this line here, this angle and this angle need to add up to make the green line. 126 plus what gives me 180? Well, that happens to be 54 degrees. So now you're looking at this idea that if you're given one angle, you know all four of those. All right, if you're given one angle, then you know all four of those. Taking this a step further, the fact that these two lines are parallel with these triangles we have here, we're told that line M and L are parallel. What that means is when you look at your alternate interior angles or your alternate exterior angles, then you're going to have congruence. Okay? For instance, and for that matter, your vertical angles. We'll get into that a little bit later. For instance, let me get my highlighter here. If I look at angle 54 right here, okay? That angle is going to be the same as this angle here because they are alternate interior angles, okay? It's also going to be the same as this angle here because they are corresponding angles. As I slide down the transversal, the next angle that I see that looks like angle 54 is that angle. So I know for a fact, because of the parallel lines, that this angle's 54 degrees and this angle's 54 degrees. All right? So, taking that a step further, that means I know that this is 126 and this is 126. Okay? So knowing one angle of the 8, I can figure out the other 7. So here's what this gives us. This gives us a list. It gives us a couple different lists, and these are very, very important, so make sure you write these down. It gives us a list of special angle pairs that are going to be congruent, and then there's going to be another list that are going to be, if I can type, supplementary. All right, so let's go ahead and let's jot these down. First and foremost, if you look at, let me go ahead and, oops, I don't want to delete that. I wanted to delete the highlight, but that's okay. If you look at angles, this angle here and this angle here, I just got done saying, obviously those are the same. And if you go back to those special angle pairs we just got done defining on the previous video, you know that those two are considered corresponding angles. So your corresponding angles are always going to be congruent, assuming that you're dealing with parallel lines cut by a transversal. In the same way, these two are also congruent. What kind of angles are those? Those are alternate interior angles. So we can also say that alternate interior angles are congruent as well. These are corresponding angles. All right. One other one, if you look at this 54 out here and this 54 here, those are alternate exterior angles. And those are also congruent. So we're getting a lot of special angle pairs that are congruent here. And then the last one that we'll talk about, if you look at this angle 54 and this angle 54, we haven't talked about vertical angles yet, but we will. And vertical angles are always congruent as well. Actually, we did define vertical angles. Those are the ones that they share a vertex, but they don't share any sides. In this particular case, those are congruent. So we have all those. Those are all congruent to each other. They're the same angle measure. Now, which angles are supplementary? Well, let's start with, and I'll switch to the highlighter here. We'll start with something like this. These two angles, those add to 180. What type of angles are those? Well, those are linear pair. Remember, the word line is right in there. Linear pair. That's a set of angles that add to make a straight line. All right, let's look at a couple other angles. How about this angle 54 here and this angle 126? What kind of angles are those? Well, they're on the same side of the transversal, and they're both on the inside of the transversal. They're on the same side, and they're on the interior, so therefore those are same side interiors. Okay? And then lastly, if you look at something like angle, this angle here and this angle, the 54, those are supplementary because those add to 180. One's on the interior, or one's on the they're both on the exterior, and they're both on the same side of the transversal. So those are same side exterior. So these are special angle pairs. When you have parallel lines cut by a transversal, you can find all the angles if you're given one and you know what the angle measures are based on what type of angles they are.